In this recording, we're going to learn about the inverse of rational functions. So we have a rational function here called f of x. And I have my colleague here, Ms. McIntosh, and we're going to try to find its inverse together. First off, Mrs. M, what should I say about the domain of this function? Are there any x values that aren't going to be allowed that would make this undefined?
Well, in order to determine that, I would have to look at my denominator, and from there I can see that if I have -7 substituted in for x, that would give me a 0 in my denominator, which would make that undefined. So -7 could not be a value, an x value.
Cool. So I guess the next question is, when I find an inverse, what essentially am I going to do to start out? If a student wanted to find an inverse, what would you suggest to them to do to start?
Well, first we would have to rewrite f of x as y instead equals to that rational function.
Alright, so something like this, where I've got a y equals instead of an f of x. Cool, so is that the inverse then?
No, that's not the inverse. You would have to continue by switching out the x and the y's.
Alright, so I'm just going to switch all the x's for all the y's. And this is tricky because before we only had one x and one y, whereas here I've got two different y values, two places where I'm writing the y. Alright, so that looks to me like that's hard. I mean, I've got this expression where I've got y in two different places. That looks like it's going to be difficult for me to get y by itself. What would you recommend I do?
So right now we don't like that rational expression, right, because it's a fraction. So what I'm going to do is multiply each side of the equation by y plus 7 in order to divide out the y plus 7's, and that would give me 1 on the right side, and I'll be left with y plus 7 times x on the left side.
So I'm going to go ahead and distribute this y plus 7 times x on the left side. And now I'm in good shape because I don't have any fractions, so that was helpful. I'm still trying to get the y's by itself. This looks complicated. What advice do you have for me?
So what I would do is try to get all of the y's on one side and all the other terms on the other side.
So which side is the right side to get them on? Does it matter?
So it doesn't matter, and there are two different ways to do it. So the first way we'll go about it is I'm going to subtract my y from the right side over to the left side.
Alright, so I'll subtract that y, and I'll do the same with the 7x. I'll get that over to the other side.
Yes.
Alright, so I can write it as negative 7x plus 4. I suppose some students might write it as 4 minus 7x would be the same. Okay, that's good, but I still don't have y by itself. What else can I do?
So x times y minus y has a y in common. So I'm going to pull one of the y's out, and I'm going to be left with x minus y, well, x minus 1, and equals to negative 7x plus 4.
I'm hoping students at this point will have a good sense of how they could get the y by itself, because you've done it in such a way where the y is a common factor of the left side. If a student still wasn't sure how to undo this multiplication, what advice would you give them?
So now I would divide both sides of the equation by x minus 1 in order to get y by itself.
Great. And I'm wondering, is that going to be the final answer then? This y equals negative 7x plus 4 over x minus 1, or is there more I have to do?
There's going to be more you're going to have to do. So since you started off with f of x as your function, you want to rewrite it as f inverse of x, and that would be your final answer.
I see. So because it had an f name, its inverse has to have inverse of f in its name.
Yes, correct.
And now I know that that is the inverse that matches that function. So that's pretty cool. Now I'm wondering, as far as checking this, I learned before that when I have an inverse, I'll call it f inverse. I have these two functions. If I put a number into f, whatever I get as the output, I could put back into the inverse, and they should undo each other. So let's see if we can do that and see if this really is the inverse, because I can't just look at this quickly and tell. What number do you want to sub in for the original function?
We can sub in 3.
All right, so let's sub in a 3, and we'll do a little mental math here in the numerator. And so if I sub in a 3, I get -1 in the numerator and a 10 in the denominator. So subbing into f of x, we get -1/10. What should I do with that -1/10 to find out if this is the inverse, the undoing function?
In order to figure that out, you would have to put the -1/10, substituting -1/10 in your inverse function.
All right, so that's going to be maybe difficult to always do in our head, so we'll go to our calculator. And in this case, just want to see that part. So I'm going to store -1/10 in x. And then I'm just going to type in this inverse expression and see if it comes out right. So if you have a calculator, go ahead and do this. Now what's the value I'm expecting to get if this works? How will I know if it works?
You'll know if it works if you get your 3 that you started with.
Okay, so did I make a mistake here?
I think it was supposed to be -4.
All right, so we think we have a mistake here, and the question is where. So let's go back and check our work. So we think we're good here with our, oh, I see my miscopying here. I miscopied the minus sign into be a plus. So I got to fix that. That's an easy fix, though. I'll just erase that and make that into a little plus sign. Okay, that makes that a plus as well. That makes that. So this is a little minus sign here. Let's use the black pen. That should have been a minus all along. That should have been a minus. That should have been a minus. We'll get this one right. Alright, so fixing this up, and maybe you students at home recognize that all along and it was driving you crazy that I hadn't caught that, or it was Macintosh, we had just let it go up into this long, but that's the thing about checking, is you do eventually get it right. So we think that's our answer. Now let's go back into our calculator and confirm that it's true. So I'll just re-enter that, and I will go back and change that minus, that plus into a minus. Good. And that's the 3 that we were hoping to get when we undid our original function. Thanks for watching.